And let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys enjoyed the long weekend. But let's actually jump into it. I have a lot to get through today. So let me share my screen, as well as make sure that I can see the chat and all that good stuff. Okay. All right. So you had a quiz yesterday. So we're going to go over that. I'll explain where the answers are coming from, even though you guys are already seeing the answers. I found that a lot of times students don't know why the answer is the answer. So let's actually make sure that we fully understand these problems. That being said, just a reminder, you should be watching up to lecture 12 today, and your test, your first test, is on Monday up to lecture 12. So test 1 covers mostly chapter 1 and covers most of chapter 1. I think of all of chapter 1, maybe there's like a section or a half a section that wasn't covered, but it's chapter 1 essentially, which we spent a long time going over, but it's very important. And I actually spoke in the last class about why that's important, went off on a mini rant. It's probably good that you guys watched that though, because some important information was given there. Wasn't scripted though, so I can't really remember exactly what I said. But yeah, so test 1 next week. The difference between a test and a quiz, not much difference, going to feel the same. The difference is you'd have to show your work. Also, I probably won't ask many definition questions. So like in this quiz, I asked you, what's the quadratic formula? Or if you have A over B plus or minus C over D, what is that, right? So those were kind of definitional kind of things. So I won't ask more of that. It will be more concepts in solving problems and actually solving problems. So that's what the test will feel like. So it's kind of like a combination of all the quizzes that we've had up until this point without those definition questions thrown in. That being said, just remember that. So on Monday, you have your first test. And now we can actually jump into the matter at hand, going over quiz 3. So the first couple questions should be no problem. So the first one is the definition that we've seen over and over. So I'll just go ahead and fill that in. That looks like this choice right here. Okay. The second one, what is the LCD of these guys? This is where you guys come again?
3x to the fourth.
3x to the fourth. So let's see, that's none of the above. So remember, the LCD is just the product of all the factors that appear in the denominator raised to the highest powers to which they appear. So yeah. So those are just a couple throwaway questions. There were a few more throwaway questions, but the quiz starts out pretty easy. Hopefully no one struggled with those too much. How did you go about combining these expressions?
First find the common denominators.
Right, so essentially you'd have to find the LCD and then you're going to create it, right? What is the LCD here?
12x.
12x, right. So now you're going to kind of multiply and divide by what you need to get all denominators to be 12x, essentially, right? So that gives us what in the first fraction, what do we need to do?
Multiply by 6x over 6x.
Well, 6 over 6, right?
Yeah.
And this one we can multiply by 4 over 4. And this one we can multiply by 3 over 3. At the end of the day, we end up with 3 6s, 18 over 12x plus 4 over 12x plus 3 over 12x. And we know when all of them have the same denominator, we can just combine the tops. So it's 18 plus 4 plus 3, which is 25. So A was the correct choice there. Okay, How do we combine this into a single expression?
You make the denominators the same by, like, for the first fraction, you multiply by x plus 7, and then the second
Right.
fraction, you multiply by x plus 3.
And you essentially multiply and divide. You can also think of this as applying the rule that we saw earlier, where we had a over b minus c over d. I know that that comes by into a d minus bc over bd, because the LCD here is just going to be the product of the two, so I can even apply that rule. Either way, you'll end up with this without too much trouble. And now we kind of just expand the parentheses to, so that would be minus, that would be plus 2x minus 35, minus, keep these in parentheses, plus 5x plus 6. And now we start to clean that up a little bit. So the x squared cancels the x squared. We have a 2x minus a 5x, so that gives us a minus 3x. And we have a minus 35 minus 6, so that gives us a minus 41. So that looks like the first one, and we can just make sure that we realize that this guy expands into x squared plus 10x plus 21. So yeah, that leaves us here. Now, in general, like I said, you don't really want to expand the denominator, but expanding was something that I really wanted to test you on here. So I gave you a bunch of situations where you had to expand those parentheses. Yeah. So the answer was again A there. Simplify completely. What is the strategy here? What do we need to do to simplify completely?
Factor.
Right, you need to factor the denominator and the numerator and then cancel the common factors. So let's focus on factoring the denominator. What do we do?
X minus 5, x minus 5.
No.
For the numerator you asked?
Yeah, you said the denominator.
Did I say the denominator? I meant the numerator.
Oh.
But yeah, the denominator is what you said. Well, that is correct. That's x minus 5, x minus 5. The numerator, if I want to factor the numerator?
You can take out the leading coefficient.
Right, you can take out the GCF. What else can we do here?
You can see that x squared minus 25 is the difference of squares.
Difference of squares, right? So that goes
x plus 5, x minus 5.
Right. And then these guys cancel. And so you're left with 2 times x plus 5 over x minus 5. Which is that. Okay, all right. Making good time here. Let's keep this up. Okay, how do we divide fractions?
You flip the second denominator, so it's multiplication.
Minus 2x minus 8 over x squared plus 5x plus 4. Okay, now what?
You factor.
Okay, so the top here looks like difference of squares. What does the denominator factor into?
x plus 2 times x plus 3.
Mm-hmm. And then this one, the numerator,
X minus 4, x plus 2.
denominator,
X plus 4, x plus 1.
right? Now you start canceling stuff. Let's see, x plus 4 cancels x plus 4. X plus 2 cancels x plus 2. Multiplying across, that leaves me in the top with x minus 4 squared over x plus 3 times x plus 1. Okay, so now that that means it's either choice A or C, probably, could be none of the above. So when it comes to actually finding the restrictions of the variables, how did you guys do that? What is the restrictions of the variables?
Don't you basically just plug in values, and if you get 0 in the denominator, then you know that can't be the answer?
Okay, so what are the values that you're not allowed?
-4, -3, -2, -1, and 4.
How do you know that? Because I mean, of course, like look at the answer here, right? That's so you know that x cannot be -3 and x cannot be -1. Where are you getting the other numbers from? It sounds to me like you're choosing choice C. Or if I worry about where the denominators are 0 here, it's those two. Where are the others coming from?
From before you cancel, because there were other numbers in the denominator in this problem.
Right. So that's something that's very important, and that's a concept that I wanted to make sure you guys remember. So I did mention in class that simplifying does not fix the domain. It's a very important thing to remember. So remember, simplifying does not fix domain issues. Simplifying is just you rewriting things that are more convenient to you in order for you to be able to do calculations easier by hand. But they don't fix domain issues, meaning any x values that weren't allowed in the beginning, they're still not allowed now. And we also see this concept when we're solving equations. Like sometimes you solve equations and you have to check the final answer that you get. You're going to realize it works in the previous equation that you just solved, but it might not work in the very original equation. And so you always have to check, you know, like in certain situations, I told you when you guys have to check. And that's because simplifying doesn't really fix the domain. If I wasn't allowed to plug in some x value in the beginning, I'm not allowed to plug it in now. That x value was made illegal throughout the entire problem, right? So for example, you'll notice that these, any x that would make that 0 or that 0 is going to be bad. Also, it turns out that any x that makes this 0 is also bad. Now that one is one that most students might have missed, even if they are aware of the concept that I just mentioned. Why is that one not allowed? The x squared plus 5x plus 4.
Because to get to the answer that we got, we had that in the denominator.
Right, so when you're looking at this, so the original problem, this was x squared minus 16 over
X squared plus 5x plus
now if I look at it like that and then all over the other one, x squared plus 5x plus 4 over x squared minus 2x minus 8. I think that was, yeah. Okay, so now when you look at it like this, notice what's happening. This is in the denominator of a fraction, so cannot be equal to 0. This is in the denominator of a fraction, cannot be equal to 0. But also this entire thing is in the denominator of a fraction, cannot be equal to 0. Now, for a fraction to not be 0, you definitely need the numerator to not be 0. So you end up with 3 things that cannot be 0. And once they can't be 0 in the beginning, they can't be 0 at the end. Any x values that allow those guys to be 0 are can't work. So now what that means is if your x squared plus 5x plus 4, x squared plus 5x plus 6 cannot be 0, that means that x plus 3, x plus 2 cannot be 0, and this means your x cannot be minus 3, and your x cannot be minus 2. Then if you look at the second one, x squared plus 5x plus 4 cannot be 0. This means that x plus 1 times x plus 4 cannot be 0. This means your x cannot be minus 1, and your x cannot be minus 4. Going to the last one, x squared minus 2x minus 8 equals not equal 0. So this means that x minus 4x plus 2 cannot be 0. This means that your x cannot be 4, and your x cannot be minus 2. So we have a bunch of lists here. X cannot be minus 4. It cannot be minus 3, minus 2, minus 1, or positive 4. So I have a whole bunch of lists here. And the important thing for you to realize is that the restrictions came from the beginning, not from the end. And that's something that's very important for you to figure out. Now, you can create extra restrictions by going through a certain process. However, all the restrictions from the beginning also have to be satisfied. Wrong one. So yeah, remember, simplifying doesn't fix your domain. So just because now it looks like only the x plus 3 times x plus 1 is what you have to worry about, that's not true. Simplifying is just like you covering up the things that make things hard for you and you're leaving. So it's kind of like you have a mess on your floor and you decide to just sweep it under the rug. It doesn't clean up the mess, it just now you don't really see the mess. And so that's how you want to think about simplifying things. It's just kind of putting a rug over it so that you can focus on the things that you need to focus on, whereas you don't have to deal with the whole mess. However, dealing with the issues of the mess itself are important. So things in the beginning, there are still issues in the end. So that was a very important concept for us to remember, and that's what came into play here. Okay, so domain of this.
3 minus x has to be greater than or equal to 0, and x cannot be 0.
Right, so this basically means that your x has to be less than or equal to 3. And I can plot those on a number line. So I can put in 0, it can be 3. And in one scenario, x has to be less than or equal to 3. And in another scenario, x cannot be 0. So someone's coming here. So ultimately, we want to satisfy both of these at the same time. So wherever I see both the red and blue lines are allowed. So it's in this region here and in that region there. So everything from negative infinity up to 0, I have to avoid the 0. And then also anything from 0 to 3, including the 3, because there's a shaded circle at 3. And so that leaves me with this option. Problem 8. What do we multiply and divide by? So this is another, hopefully it was a throwaway question. You don't really have to do any calculations, just knowing a strategy. What is the correct option here? Anyone?
Multiply and divide by square root of x minus square root of a.
Okay, so that's option B. And it's very important that you realize why we can take advantage of difference of squares in the numerator. So again, it's not always you just change the middle sign and multiply and divide. You do what is necessary to take advantage of a formula. Just that when it's square roots, that's what it amounts to. But it's because there's a formula that you're trying to take advantage of. If it were cube roots, then this strategy would not work, and it's very important for you to recognize that. And in this quiz, I only gave you square roots to rationalize, so it didn't get too difficult. But of course, in the test, I do expect you to know how to deal with cube roots and beyond, and try to know what you would have to multiply and divide by to get something to work out when it's not necessarily just a square root. So it's very important that you know why you're doing this. And this actually came up in the last class as well. The idea of just kind of mindlessly doing something because you've seen your teacher do it a million times. And so you kind of tell yourself that, yeah, I know how to rationalize stuff. And that's because every time I did it, I got the right answer, because you've always done problems where there were square roots and you just had to change the middle sign. So now you just think changing the middle sign is the right way to attack this problem. But then you get with cube roots and then it doesn't work anymore. And then all of a sudden it's confusion. Math is so hard, it's just crazy. And it's not that it's hard or you didn't really, you weren't really putting in the work, but it's like you completely came away with a different idea than you should have come away with. And a part of that is just going through the motions and not really knowing why you're doing it. And as I was mentioning, that causes a lot of havoc. So it's very common for students to be like great at math when they were in high school, but then they come to college and then everything just goes out the window. And, so I'll often hear people say things like, oh, math in high school, I was so good at math. And, ever since Calc 1, then suddenly it all changed. Or ever since Calc 2, suddenly it all, like everyone has a point where things flipped for them. And usually that happens because back when they were good at math, they were good at it for the wrong reasons. They were good at it because the problems were always the same, and the teacher taught to the test, and you never really know why you were taking each step. You just know, when I see this problem, I just take these steps, but I don't know why. And then you try to apply that reasoning to college math, and it just doesn't work, because at this point, we expect you to understand why certain procedures were taken, and you should be able to vary your technique and adapt to the problem at hand. Whereas, a lot of high schools just don't teach that way. They're just like, well, we're only ever going to ask you to rationalize something with square roots. So just know that you change the middle sign and multiply and divide by it. And then you end up in trouble because you don't really know why that was the case. You just know that that's what you did. And so you get all these problems right, and you get a good grade, and you're a superstar in high school math. And then you come to college and then it's all different. So that's a part of, in terms of the examples with the cube root, I actually did that in the last lecture. So we actually spent a long time on that. So you probably want to rewatch the last lecture and do that. I did several different situations of rationalization. So But in this quiz, we only needed these knowing the square root. Okay, so watch the last lecture for rationalizing. We actually went over that in detail. Okay, for this one, it's actually the same concept, right? Because these guys only have square roots. The difference is here, we want to rationalize the denominator, not the numerator. So we are going to start off with this guy. And now my focus is on getting rid of the radicals in the denominator. And I know because of the difference of squares, I just change the middle sign and multiply and divide by that. So this leads to, in the denominator, it'll just become radical 3 squared minus radical 6 squared, right? That's why I multiply by that. And in the top, I would have radical 3 minus radical 6 all squared. So the denominator now becomes 3 minus 6. What happens to the numerator? What does the numerator become? Anyone? No ideas?
I'm not sure, but I think it's gonna be 3 minus 2 times radical 3 times radical 6 plus 6.
Okay, why do you have that idea?
I just put radical 3 minus 6 minus radical 6, and I multiplied that by radical 3 minus 6.
Okay. Or you can just remember that a minus b all squared is a squared minus 2ab plus b squared, right?
Mm-hmm.
So if I have radical 3 minus radical 6 all squared, that's going to be radical 3 squared minus 2 times radical 3 radical 6 plus radical 6 squared. So that's just 3 times minus 2 radical 3 radical 6 plus 6, right? And when you know this is something that you'd be able to do in your head. So you just know you square the first term minus 2 times the product of the two terms plus the square of the last term, and you can get to that. So that's what that would actually expand into. So cleaning this up a bit, we have 9 plus 9 minus 2 radical 18 over minus 3. So I check for that answer, and that answer is not there. So what can we do? Can we simplify this a little bit more? How would you go about simplifying this?
Nine divided by negative 3. And it will be, I will just take 9 divided by negative 3 and negative 2 over negative 3 and simplify it.
Okay, so like this.
Yes. And you will
Okay.
end up with negative 3 minus,
Will become a plus.
yeah.
Still not looking like any of that. Anything else we can do? Other ideas? Like, I mean, we pretty much simplified everything. There's only one thing left that could possibly be simplified, right? And that's the radical 18. How would you go about simplifying the radical 18? So simplifying radicals, also something that we talked about last time. How do we do it? Any ideas?
It
Yeah.
would become 2 times 3 radical 2.
How did you get that?
The 18 will be 2 times 9, and the 9 is 3 times 3.
Okay. And we learned about simplifying radicals, that you can just open up 2 radicals. You put the guy that simplifies in the first one, you put the guy that doesn't simplify in the second one. The radical 9, that is just 3. So then you have minus 3 plus 2 times 3 times rad 2 over 3. And the 3's would cancel. So this actually did simplify a little bit more. And so you'd end up with minus 3 plus 2 rad 2 as the full simplification. And that's here. Okay, so another thing I just want to bring up with this problem. Notice that there is a lot of things that had to come together here to get through this problem. So first of all, here I need to know how to rationalize. Here I need to know how to expand a square. I mean, over here, yes, I need to know how to factor and cancel stuff, and you can split it up here. Here, I needed to know how to simplify radical. Here, I had to cancel again. Okay, so look at this one problem here, right? Now, it was a very long problem, relatively speaking. However, you'll notice that at each stage, there was only really one thing to focus on at a time. Right? And in theory, if you know how to do each of these things, you should know how to get through this problem correctly. And so this kind of goes more into why we actually go through chapter 1 so slowly. I know some of you have commented on it, but I'm really trying to simultaneously undo some of the bad habits that you got in high school while really setting you up for success in the future. And for a while, this is the following is going to be true, and you should take this to heart, because yeah, for like, even if you're a math major, for like the first 2.5 years of math classes that you take, the following thing that I'm saying is going to be true. Difficult problems are just combinations of a lot of smaller problems. And that's true across the board in some situations, but math eventually gets a lot harder than just breaking everything down into the simplest step, right? That's not always obvious, but for a while, that's going to be the case. It's going to be true in this class, true in calculus, calculus 1, calculus 2, calculus 3. Like every time you end up with an issue, what you really should be aware of is that, you know what, there's a small step that I'm missing. There's some building block that I'm missing that I don't fully understand. And so in this class, how I've structured it is, in chapter 1, I go through very slowly because these are the building blocks. And essentially, whenever you get to a problem that is more complicated, what you're really doing is you're breaking it up into bite-sized problems. You're taking care of each little thing one at a time. And so if you know each of those little things one at a time, and you know the overall strategy of approaching a problem, that's what leads you through the problem. So once you know the overall strategy, basically it tells you what you should be doing at which stage. And then by knowing each individual stage in and of itself very well, you can actually execute each individual stage. And that actually gets you through the problem by almost following your nose once you actually learn all the strategies and the rules and the techniques correctly. And so that's why we're kind of moving as slowly as we can, because chapter 1, yes, it's easy, but it's easy in the sense that a lot of people think it's easy for the wrong reason. They just mindlessly go through the motions that they've just seen their high school teacher do 1,000 times and that they practice the test 1,000 times. So they feel like they know everything. But then when it gets down to it, do you really understand what happened at this step? And the answer is no. They don't know why that's the step, or, someone's got no idea. I have no ideas as to why this actually happened. And that is the issue. That's what I'm trying to clear up by going very slowly through chapter 1. So really understanding each individual steps, knowing the overall strategy so that you know when to apply each step. But in fact, each of these guys were dealt with in a separate lecture where I tell you, like how to go from this line to that line. There was a whole lecture on that. Like, this is how you simplify a radical, right? There's gonna come a point in a problem where at some step, you're gonna need to simplify a radical. And you need to know how to do that very well so that you don't lose a beat, right? You'll be able to continually just grind through something, and you know exactly what you need to do at each stage, and you actually know how to execute what you need to do at each stage, right? And so this problem is it's a combination of a lot of different things. Like this is a combination of like 4 different lectures in this one problem, right? And so really knowing the steps and the strategies are going to be very important. And not only are they important into getting through the problems, but they set you up to think about things correctly, to actually know why you're doing what you're doing. And when you're in an unfamiliar situation, you still can lead your way out of it. You can solve the problem because you understand the principles that you're trying to apply. And you're not just good at specific numbers or specific situations. You're good at figuring out how to solve any problem in a class, right? And that's where that is the goal. And that's what was required for this problem. So a lot of situations, not only knowing how to rationalize, but going through the simplification process required us knowing a lot of individual things that hopefully you've been paying attention to, and you've been taking notes, and you've been following my advice that I give you in the lectures. So you're already here. So be careful when you're studying and you're trying to make sure you're not just doing the problems and redoing the problems that I did in the lecture and redoing your homework problems because you're just like going by rote through the things. You need to fully break things down and understand. Try unfamiliar problems. Whenever you get them wrong, make sure you pinpoint the line where you got them wrong, and then you can say, okay, I made a mistake here. Why did I make that mistake? What is the simple building block that I'm missing, et cetera, et cetera. And then that's how you actually build on it. So I actually had a meeting with a student during office hours, and this is basically what we kind of went through, where this student was actually familiar with the overall process of things. And it was very frustrating to them because they realized that they weren't doing as well on the quizzes as they thought, because they felt very confident. But then when it came down to it, their grades just aren't reflecting that. And they're like, I don't understand. And so when it came down to it, the thing that student had to focus on, and I assume a lot of you also have to focus on as well, is really, yes, you might know overall what the process is, but sometimes it comes down to you actually breaking down the individual steps and really making sure, do I understand the individual steps, right? Really making sure that if you got a problem wrong, that you can identify at what point did I go wrong, right? So if you got this problem wrong, for example, you should be looking at your work as I'm going through it, and you should be doing something fairly similar to me, but the moment that you do something that was different, like maybe you didn't simplify this radical, you need to asterisk that line. You need to make sure that, oh, this is where I messed up. Because sometimes it's not just knowing about the general strategies or just going through the motions. It's not just about the problem itself. It's about understanding your reaction to the problem, right? And this is something I also mentioned again that's worth repeating. Like, you have to know yourself as well as the situation you're in, as well as understand the people in the other situation you're in, right? Like that famous Sun Tzu quote, you have to know yourself and the enemy. Like, if you only know one or the other or neither, you will be defeated in battle very regularly. The person who is successful most of the time is the person who understands the situation, but also understands themselves. So not only should you be going through the problems and learning what to do and knowing the strategies, but you should also know at each individual steps, what are the kind of mistakes that I would make, and what should I focus on, and what are my misconceptions? Because you can know the strategy, but if you approach it and you don't have the skills and you have a bunch of misconceptions, you'll never be able to pull off the strategy. And that ends up meaning lower performance than you expected, because you'd have a level of confidence. And it's not that it's misplaced, it's just that there were other things that you should be confident in as well that you didn't even know you should be confident in. And you know, it just ends up, the mistakes fall under the radar, right? So this is why I kind of throw these questions out to the class. What do you guys think I should do now? What do you guys, right? Because I want you to know at this step, what is the next best step? You know, you need to understand what we're doing here, right? And that's how you really bridge the gap between what you think you know and what you actually know, because those two things are very different. And at the end of the day, it can be quite frustrating when you're studying for hours and you feel like you know something, and then the test results come back and you realize that, oh, well, you know, and then at that point, this is where people start misdiagnosing. Oh, you know, teacher's trying to get me to fail, or math is just hard, I'm not a math person. You start throwing up all these ideas that none of them are true. It's just that you weren't really focusing on the things that you should have been focusing on, right? And that's what I'm trying to get you guys to do. So that's another shameless plug for the defense of my strategy in going through chapter 1 very carefully, because it adds up. Like, so even when you get to the more complicated type problems, you're going to realize the reason you're getting those guys wrong is because of the simple ideas that you're forgetting, right? It's that in the minutia, going through the details, that's what you're messing up on. So, and that's going to cause a lot of frustration if you don't recognize that. Yeah. So that's the mini rant for this class. I had a slightly different rant for the other class, but maybe you guys should watch that. Anyway, it's important that you pay attention to these, because now you're at the ground floor. I'm telling you what you'll need to have success in the future. So just pay attention to this, and your studying will be more efficient. It will be better. It'll be longer lasting. It will, all that good stuff will be good. But let's actually get back on track here. Yeah, linear equations. People usually don't have problems with this. So hopefully you realize that the thing that you'd want to do is subtract the b, then divide by the a. Right? When you want to solve a linear equation, the goal is to isolate the variable you want to solve for. And you do that by doing the opposite operations on the other guys to move them to the other side. Find all solutions. What are the solutions to this equation?
Zero and 1.
0 and 1. By the way, common mistake, and this is even more detrimental when it comes to inequalities. Like if you were to have like x squared less than x, a very common mistake that can happen. So I want you to be aware of this. Common mistake is for a student to have x squared equals x, and then what they did was they divide both sides by x. And so they get x equals 1 as the only answer. The problem is x equals 0 is a solution. So dividing by x, you could be dividing by 0, and that will cause you to mess things up. So that is the common error that can happen with a problem like this. Students just thinking that they can divide. Let's actually look at the correct way to do this. So we have x squared equals x. What is the strategy for solving this equation?
Subtract x so that one side of the equation has 0.
Right. Bring everything to one side so that the other side is 0. What is the next step? Factor. Then you set each factor equal to 0 because of the 0 factor property. If you follow that strategy, you'll realize you get both solutions because that's the correct way to do it. So just because you can do something like dividing both sides of an equation doesn't mean you should, because if you don't follow the correct strategy, it can cause you to miss things. So it's very important that you know those, right? It's why, again, spend a lot of time going very slowly through chapter 1. And I tell you every time I'm doing something, this is the strategy. These are the things I was thinking about while I did this. These are the things you need to remember. These are the rules. Here's when you should apply this rule. Here's when this rule doesn't apply, right? Like it's very, very important. This is just quadratic formula, something that you should just know, another throwaway problem. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. Looks like the second one. Okay. So that's just something that you should know. It was derived using completing the square, but I don't recommend anyone completing the square to derive the quadratic formula. Just something that you should know. Completing the square is something you should know in general. Otherwise, but to actually just write down the quadratic formula, you should just know that by heart. All right, let's look at this one. The last class also had a lot of trouble with this one. So let's see how you guys are. What do you think? What's the solution here?
Can you square both sides of the equation first?
Okay, so we have, it was 2x equals 1 minus 2 minus x. So you wanted to square both sides? Okay, and what do you get?
Do you get 4x squared?
Mm-hmm.
Equals 1 minus 2 minus x.
Okay, so is that okay so far?
I don't think so.
No, this is wrong. Why? Why is it wrong?
Oh, can you add? Wait, no. Can you subtract the 1 first?
Wait, let's stay here. Let's figure out why this mistake happened. What's wrong?
A minus b quantity squared is a squared plus 2ab plus b squared, and that's not what we did here.
Right. So we made the mistake of distributing powers across sums. Right. That's the error that happened here. Okay. So this is another tip that I want to give you guys when studying, and this came up in a couple office hours that I was in. Right. So you're doing a problem. You're going through the steps. You get something wrong. Right. And the knee-jerk reaction would be to, okay, let's backtrack and just go another way, right? So like we got this wrong, and then the suggestion was, oh, maybe we should go back and move something to the other side first. Okay, when you do that, you're actually doing yourself a disservice. When you make an incorrect step, you need to stay at that step. Figure out, why did I get something wrong here? What is my misconception? what is the problem? Like, why was this set off, right? So when you like go to a tutor and you're showing them your work and they're like, okay, you got this wrong, it's not good enough to know that you got it wrong. Ask the tutor or anyone to tell you, can you tell me specifically at which line I did something that was wrong? Go to that line and spend time at that line. Make sure you fully understand why you were wrong, what misconception you had. And it turns out this one is a very common misconception. It's why I put it in the syllabus and say you should never do this and all that stuff. So distributing powers across some very common error. It happens even when you know it's not the right thing to do, right? So in the first stage here, what you really had was an a minus b all squared. That expands to a squared minus 2ab plus b squared. So that should be 3 terms that you should get here. So really, the correct line would have been 4x squared equals 1 minus 2 times radical 2 minus x plus 2 minus x. That would be the correct next line. Now, there is another thing that was an issue with this problem. Okay, notice what happens here is I still have a radical to deal with. So now I'm going to do squaring again. You're going to notice that you're still going to have a radical to deal with if you just decide to square again. And so now you start to realize, okay, now maybe there was a problem, because now even when I'm doing the right thing, this doesn't seem to be getting any better. This doesn't seem to be solving the problem. And so now you start to see, yes, this is a correct line, but not helping, right? I mean, it's not getting better. So here, it's not a matter that you made a mistake. It's more a matter that you're not following some strategy. Like so here, this was a computational error. Where you actually got something wrong. You need to stop and realize why that was wrong, right? And you need to fully understand why that was wrong. You need to make a note of it. You need to make a big deal about it. You need to write in a different color ink in your notebook that do not make this mistake. You need to make it important to you so that you'd always, in the back of your mind, eventually you'll just know that that's not something you can do, right? That's like the blue car syndrome, right? If you buy a new blue Honda Civic, suddenly you start to realize there are a lot of blue Honda Civics around, right? Your brain starts to notice something once you make it important to you. So you point it out, you make a big deal out of it, you spend some time, you really get it. So now you can repeatedly see that mistake. Eventually, when you do pay attention to the distributing powers across sums mistake, you are going to eventually start to know that I can't do that. Now, there are times when you did do the right thing. Like this, the blue line is really what follows from the line previous, right? So going from this line to this line is correct computationally, but it's just not efficient. It actually puts you into a worse position, right? So there are a couple kinds of mistakes you can make. And I did talk about this in the last lecture as well. There are things that are outright flatly wrong, but there are also things where it wasn't the best thing to do. You're not wrong, but you kind of put yourself into a position where now you're at a disadvantage. You make it harder for you to get the problem right, right? So while the step wasn't wrong, it wasn't very efficient. It wasn't the best step to take in terms of solving the problem, because now you end up with this new equation, and it's far more complicated than the original equation. Like, what was the point of doing that step? You end up in a worse situation, right? So whenever you realize that you have something that technically is correct, but it didn't help, this means it's a strategy error. Okay, so when you're studying on your own and you're going through a problem, right? And you're actually studying, right? Another thing that happens all the time is students actually put in the time to study. They spend a lot of time and then they still do bad because they don't really know how to study. And so that's what I'm trying to get through to you. You need to understand the two main types of errors you're going to make. There's things that it's outright you're just disobeying the rules, and there are things where you're not following the right strategy. And so you just make your life harder. You need to be able to identify both of these kinds of errors, and you need to fix them. Whenever there's a computational error, you need to go back to the rules. Whenever there's a strategy error, you go back to the strategy. These are two different things, and they're two different ways of dealing with them. The computational errors, that usually means there's just a lack of understanding. Like there's actually something that you don't understand how the math is working. Whereas the strategy error, it's just a lack of not memorizing the steps. So it's not like you have an erroneous way of thinking about things, but you didn't memorize a bunch of things that you should have memorized, right? So memorizing can help with strategy errors, whereas fully understanding is what's going to help with the computational errors. And you need to identify these and you need to figure them out. So it's a strategy error. This strategy, so let's so now go back to the original problem. Okay, now strategy-wise, what is the thing that we should be doing?
Isolate the radical.
Isolate the radical. This was the first step in the strategy, and there's a reason for it, right? Because you don't want to end up in either of these situations. You don't want to end up in a situation where you're going to make a computational error. You don't want to end up in a situation where you're going to make a strategy error. And it's not that it's wrong. It's just that now you're making your life so hard. However, if you follow the strategy and you first isolate the radical, which is the first step in the strategy, then you decide to square both sides. Now, a couple things are going to happen. Yes, it is possible for you to distribute powers across some and make that error here, but I can tell you for sure, especially if students are studying well and they're paying attention to it, it is less likely for you to expand this incorrectly than it is for you to expand that incorrectly. And that's because of just how the human mind works. The more unfamiliar the situation, the more likely you are to make a silly mistake. So expanding something like this is something that you do very often. So you're more likely to catch a mistake when that's happening than expanding something like this. I mean, how often do you expand something like that? Not very often. You're used to expanding things without radicals all the time. Things where there are like radicals and subtractions in it, you're not used to expanding those. So it's very easy for a mistake like a distribution of powers across sums to kind of creep in under the radar, because you're in you put yourself in an unfamiliar, disadvantageous position. As opposed to here, you are now in a position of strength. You're in a position that I've been in this position thousands of times. It's less likely for you to make an error expanding the left side of this equation. So on that hand, you're not going to make that error. And now the added benefit is, because of the strategy, I now eliminate the radicals after one round of squaring, as opposed to in here, even if I'm doing things correctly, I would end up having to square again to get rid of that middle radical. I've now added an extra set of steps, and I have to worry about more terms to do those steps with. Like this, it's not incorrect, but it is very inefficient, and it puts me in a position where it's like, man, my life is so much harder now. I'm gonna have to square a bunch of times, and I'm not getting into any easier position. As opposed to here, following the strategy puts you into a much nicer position. It gets you there a lot quicker, and it gets you there in a way that you're less likely to make a silly mistake while getting there. And this is the point of knowing the strategies. So when I go through the class and I give you the strategies and I write down in English sentences, here is the first step, here's the second step, here's the third step. It is very common for students to gloss over that, and they just focus on me actually working through an example. That is not what you should be doing. You should be focusing on the strategy. Knowing the list of steps is more important than paying attention to the specific example I'm working through. Okay, so have your priorities straight when you're studying. Knowing the strategies is what's going to guide you. Because even if you know how to execute correctly each individual steps, not knowing the overall strategy is going to put you at a disadvantage. And even though you know the right things to do, you're just going to have to work harder to get them done. And this causes a lot more opportunities for mistakes to creep in because now your brain is tired, you're getting frustrated, the problem is just dragging on. And so eventually your brain is just going to try to do a shortcut to just get out of it. And it's going to end up making the wrong choice at some point. Don't give your brain the chance, right? It's trying to save you, but it's going to pull a bunch of shortcuts to save you that it shouldn't pull. And to protect yourself from that, knowing the strategies will protect you from that. So we get to this new equation, and we know the strategy for this at this point. Bring everything to one side and factor. Need to make the other side 0. I need to clean this guy up so I can factor. And at this point, I am going to try to factor. So I can do a 4x and an x. It has to be a 1 and a 1. I can do my check. This here is 4x. That here is x. Can I get to a minus 3x? Sure. If I make this a minus and a plus, I can get that. And so I need a minus here and a plus here. And so now I have 4x plus 1 equals 0, or x minus 1 equals 0. And my x is going to be minus a quarter, or my x is going to be 1. And then we need to remember, whenever we're doing a problem like solving a radical, we do need to check our answers. So if my x is minus a quarter, and I want to know, does 2x equal 1 minus the radical of 2 minus x? So on this side, I would end up with minus a half. On this side, I would end up with 1 minus 2 minus a quarter. Plus a quarter. This would be 9 over 4. This would be 3 over 2. And so that's also minus a half. So this one checks out. If I go and try the x equals 1, and I want to know, is 2x equal to 1 minus the radical of 2 minus x, and I plug in x equals 1 on the right side, I get 2. If I plug in x equals 1 on the left side, I get this, which is that, which is that, which is 0. Does not work. And so only the x equals minus 4 is the answer. And so I go up and I plug that in. Okay. And again, I spent a long time ranting, so it took forever to get through this problem, but the rant was important. Pay attention to the rant. Again, this is a longer problem, but if you know the general strategy and you know how to execute each step individually, you should be able to get through this relatively quickly. So I did have a lot of people finishing early, and even when I did them, if you know what you're doing, it's not going to take a long time, really. But it's only if you know what you're doing. If you're doing something like this, then yeah, it'll take you forever, even if you know what you're doing. But if you follow the strategy, you'll get to the answer, you'll get to there a lot more efficiently. Okay, and I've had 2 rants in this class so far, so let's actually just pick up the pace here. Let's keep going. Okay, so this one, it seems like something you'd have to do calculations for, but it's not, because what I can notice here is there's a negative sign. Absolute values will never be negative. So if someone tells me the absolute value of x minus a is equal to minus 5, no, it's not. Right, so this is, you didn't really even have to work anything out here. Just noticing that an absolute value can't give you the negative means that there are no solutions to this. So that was actually a computational question, conceptual question. Question 15 is computational, that you have to know how to deal with absolute values for. So for this, we have absolute value of x plus 5 equals 2. Remember the absolute values, whether or not the inside is negative or positive, it will return the positive 2. So you have to account for both cases. If the inside is positive, the absolute value does nothing. If the inside is negative, the absolute value is going to take the negative of the inside to make it positive. So here I would have x equals -3. Here I'd have minus x minus 5 equals 2. And so I would get x equals -7. And we can check these answers. And you'd realize that they both work. So that leads you to -3 and -7. Problem 16. I want to solve this equation. What is the strategy? What is the first thing I do?
Find the LCD.
Find the LCD. LCD is, looks like a minus 6 times a plus 6. Now that I find the LCD, what do I do? Okay, you guys need to know the strategies. How do you know whether or not you know the strategy? Basically, you should be able to answer these questions, right? So like when I ask you, okay, what do I do now? What do I do now? What do I do now? If you don't have an immediate response, you don't know the strategy. Find the LCD, multiply through by the LCD. So you multiply both sides of the equation by the LCD. Now you don't have to write that step because it should be, with practice, you'll see in your head what's going to happen very easily. But let me just write out the step at this point for the sake of completeness. So you don't have to write this step out, but I would just note that you would multiply the first term by the LCD, plus you multiply the second term by the LCD. So you multiply all terms by the LCD. Multiply both sides by the LCD. That was the strategy. You'll notice now things will start canceling. And essentially, again, with practice, you'll be able to actually see that in your head, what's going to cancel, what's going to be left over. But eventually you're going to be left over with just an equation where there are no fractions. Right? So multiplying by the LCD puts you in that position immediately. Right? There is something that students like to do where they combine the fractions on the right, they combine the fractions on the left, they move to one side, and then they combine those fractions. Not wrong, but not very efficient. There's a lot of opportunity for errors there. And if you're not tight on your technique, you'll make an error. Multiplying by the LCD is the fastest, most efficient way to get out of the fractions scenario. So that puts you here. And at this point, it is a linear equation. So you're just going to isolate the a. So here you'd have 2a, bring the 12 over to the other side, minus 18, you get a equals -9. And again, you do have to check, but in this case, I think that worked out. Remember your training grasshoppers, remember the strategies. They are your guide. Okay, the rules are your guide, everything's a guide. Okay. For this one, just for you to see some incorrect things that could be done here, and hopefully you realize that the error happened here because this situation shows you that x minus 1 equals 0 is possible. So a division by 0 occurred. And that's going to lead to the wrong problem. So if we want to know the wrong solution, so if we want to know where the mistake happened, it happened at this step. And like I said, it's very important that when you're working through your work, that when you get something wrong, don't just say, I got it wrong, let me start over, or what was the right way to do this. Have someone, your tutor or whoever you're working with, identify specifically where you made that error. And you need to know why you made that error, because you're not always going to be lucky to escape the situation that would cause you to make the error. So you need to know how to deal with the situation if you're forced into it. And knowing the strategies and how to be efficient will get you into positions where you can make mistakes less often. But at the same time, you're always going to be in a position where you can make a mistake. So you do need to know the correct way to handle each situation. The strategies will minimize, knowing the good strategy and following it will minimize the amount of times where you have to make difficult decisions, which is very, very important. You make difficult decisions all the time. You're going to mess up at some point, right? If to get a problem right, I only have to make 2 good decisions, then more than likely I'm going to get that problem right than if I had to make 15 good decisions, right? The chances that I can make 15 good decisions one after the other and get them all right is a lot smaller than the chances of me having to make 2 good decisions and getting them all right. So put your make sure that you're in the former situation. Having a good strategy is what you need. What I would do here is to get rid of the fractions. I would actually multiply both sides by 3. I would try to factor this. So 2 numbers that I multiply, I get positive 12, add and get negative 6. Can't really think of anything. So what happens when I can't factor? What do I do?
Use the quadratic equation.
Quadratic formula. So I go into minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that's going to be 6 plus or minus the radical of, this is 36 minus 48. Well, that negative means no real solution. So how many solutions does this have? 0 real solutions. So 19 was, again, just checking some conceptual checks as to, do you know the correct way to simplify? What's allowed, what's not allowed?
I have a question about 19. Like, if you didn't choose all the correct answers, you can't get partial credit for choosing like 2 of the correct answers?
No. Because at this stage, because I've done this so often and it's been re-emphasized, it's really not the kind of situation where I would expect you to make a mistake at any point here. So one that you should realize is correct, that you should realize is correct, and the others are wrong. And the others come from common mistakes. So the second one is wrong because of canceling across the sum. The third one is wrong because that's distributing powers across the sum. And the last one is wrong because you can't split a fraction across the denominator, which actually, case in point, students forget that, even high up. Like, I had a couple of my Calc 2 students making mistakes with that. So don't fall into that trap. Like, if you have to know that that's not allowed. Last question. So again, the strategy here is to find the LCD, multiply and divide by the LCD. It is the quickest way. To get this to work. And so what you do is you take the LCD, you multiply this, you multiply that. Take the LCD, you multiply this, you multiply that. And if I multiply the 1 over x plus 1 times x plus 1, that just simplifies to 1. If I multiply the 1 by that, that simplifies to that. Multiply the 1 by that, simplifies to that. Multiply that, it cancels. So I end up with 1 minus x minus 1 over x plus 2. So that's just minus x over x plus 2. Okay, so we're a couple minutes over time, but let me just run through the last two bonuses. This one is supposed to be quick because if you just know the equation of a circle, the general formula, it's going to be easy to pick out the actual answer. Realize that the right side is the square of 5. This is r squared, so the radius is 5. And the center is going to be the negatives of the numbers beside the x and the y. So there's a -3 beside the x, so it's a +3. And there's a +4 besides the y, so change that to a -4. And that leaves you with this as the correct answer. So that's just something to know. And the last one, I think, did require some calculations, but it's inequalities with absolute values. So the strategy, as you will see in future lectures, is to first isolate the absolute value. So I can subtract 3, I can divide by 2. Because I'm dividing by a positive number, the inequality sign maintains its direction. If I divide by a negative number, I have to flip the direction of the inequality sign. Also, if I take reciprocals and both sides are on the same side of 0, I have to flip the inequality sign. We talked about that in class. And there's a rule that says whenever you have an absolute value less than or equal to something, you can actually put that thing on either side of the thing that is in absolute values and make the left side negative. Now I can add 5 to all sides. I end up with x's between -20 and 30 inclusive. And that leads me to that being the correct answer. Okay, so that was the quiz. So hopefully you understood everything. Pay attention to all the things that I mentioned. We discussed a lot of important concepts in today's lecture. Went off on rants a couple times, but it's very important in terms of making sure you're studying efficiently, making sure that you're actually learning, making sure that you can perform as well as you believe you understand. And it will reduce your frustration and your rate of failure in the future. That being said, we're going to wrap up there. Thank you for your attention. Thank you for your participation. As always, I'll post the video and the lecture notes on YouTube. So that being said, have a good day, everybody. I'll see you guys in the next one. Ciao.